Hello everybody and welcome to today's episode of CCIR Student Research Spotlight podcast. I'm your host Nell and today I am welcoming to the show Sricheta, who is in her 12th grade in India. Whilst with CCIR, Sricheta works with Dr. Alexander Mushtakov and her project was titled The Spectrum Due to Outflows in X-ray Pulsars, which I do not understand what that means at all. I'm hoping she can shed some light on that. So welcome, Sricheta. Thank you for joining us today. I'm just wondering if you could start by explaining what your project is and basically enlighten us on what your research is on.
Yeah, certainly. So there in the universe, there most of the stars are exist in pairs. So they have companion stars. So in this research, I was focusing on neutron stars, and since they have really crazily huge magnetic fields, and since they're so dense, they have a huge gravitational field. So they attract a hell lot of matter from their companion star. And there are outflows from the secreted matter in the form of X-ray radiation. So basically what this project was about, my mentor gave me some equations which would be useful in describing the trajectory of a photon after it would be emitted from the surface of the neutron star. And these equations would be based on just two angles, and they would be helpful in predicting the points at which the photons collide with the surface of the accreted matter. So it collides at a point, and then it has a new trajectory which is described by some new angles, and these angles would be generated by some random numbers. So all this involved a code, and the code would generate some random numbers, and and the code was made in such a way that it would help in finding out the points at which the photons would collide, and basically the entire history of all the photons before they left the system of the neutron star and the accreted matter. So this would help in finding out the distribution of where the photons collided, where they collided the most, where there were not many collisions. So it would help in getting an idea about how hot different layers of the surface is, and then this would help in finding out the temperature and then hence the spectrum due to these collisions. And what this finally does is that when we observe the surface from different directions, there are some discrepancies in the spectra observed. So this research basically it's an attempt to explain some of those.
Wow. That sounds incredibly complicated. Too much my non-mathematical or scientific brain. So how did you become interested in this? What background are you coming from in terms of your studies, and how did you go about choosing this as a point of research?
So I was really interested in how high density objects like neutron stars and black holes behave. They exhibit some really strange and crazy properties because of their high densities. And I was always interested in the Big Bang and high density astrophysics. So I chose this course.
Wow, fantastic. The only thing I know about astrophysics is the Big Bang Theory, so don't think I can really relate.
Yeah.
And so you had an interest in astrophysics already. How did you find joining somebody else's ongoing research? Because you said that you joined Dr. Mushtakov in working in this area. How did you find approaching the academic environment? And I wondered, did you have any experience of research before?
No, I did not have any experience in research before. And I mean, there was a really big realization which I had after this research project. So initially, I was aware that physics does involve a lot of mathematics, but I never knew that there's a huge coding side of physics. I never knew that it would involve so many codes and everything. So it was after this project that I actually realized that in high school, the physics problems which we have are pretty idealized, and and they're idealized in such a way that the expressions we get are also such neat and tidy that we can actually simplify and get them in a neat and tidy way. But that's not how real life works, and sometimes the equations are so lengthy and complicated, and there's so many interactions involved that coding is inseparable. And in fact, modern day physics cannot exist without coding. And at times, things are sometimes like in neutron stars, in the vicinity of neutron stars. I don't think, I mean, it's really feasible to test or observe some things because they behave in a really crazy way. So in such cases, codes are very important for using, as I said, some random numbers and getting a picture of what's actually happening by considering some random situations. So I mean, a big learning which I had from this project was about how physics and coding are so related.
Yeah, fascinating. I've never really thought about that. And so was coding something new to you that you had to learn for this specific project, or were you already slightly familiar with coding?
No, I luckily actually I was doing an informatics practices course in school, so I already had the required knowledge. But I mean, it was at the coding which I do in school is at a beginner's level. It's basic, but so I had the existing knowledge, but I had to stretch a bit and use syntaxes in a creative way in this project.
Yeah, that's great. That's great to hear that it was a challenge as well. And so do you feel that you know, whilst with CCIR you were stretched and do you feel like you've learned something and that you've expanded your skill set, perhaps not just with coding? Do you feel like it's helped in other areas?
Yes, I really feel it kind of really challenged, and it improved some mathematical skills as well. So, I mean, even in the code, I mean, there are different equations and functions. So sometimes some crazy things happen, like the denominator becomes zero, and in such cases, the code should not produce a syntax error. So in such cases, I had to look carefully at the equations, and then I had to think about what happens in those special cases. And before incorporating them into my code, I had to assess if they're actually physically possible, because there is no use incorporating something in a code which actually is just mathematical and not physically possible. So, I mean, I also really like this aspect of combining physics and maths and coding.
Yeah, wow. It sounds like you've had to be incredibly, as you said, sort of creative with this and really think outside the box in your approach, which is fantastic. Yeah. And I wonder, in this course specifically and in the sort of world of maths and physics and coding, did you feel comfortable with CCIR? Did you, I suppose, were you doing it all online? Because I was wondering if you managed to make any friends or how you found interacting with other people on the same course, what your experience of the sort of social side was.
Yeah, so I mean, this was a one-on-one mentorship, and I was working personally with the professor, and he was really, very, very willing to help me with the equations and with the code. So whenever whenever my code would not work properly, it would give some debug. I mean, he would help me debug the code, and also in case there was some prerequisite knowledge required which I had not covered in school yet, like matrices, etc. So he taught me all those things which was necessary, and he was really patient with it. So I kind of really felt really, really supported.
Oh, that's fantastic. I'm glad to hear that. Because were you nervous before starting, or excited? How was the sort of, what was your process to get to CCIR, and how do you feel you've come through at the end?
So, I mean, initially, actually, I was looking for some courses which would give me a formal understanding and maybe some research experience in astrophysics or quantum physics. And then actually, my mom came across CCIR's program on the internet, and then she gave me the information. And I was initially a bit daunted because I felt like I had basic coding experience, and my professor informed me that coding would be necessary. So I was not sure whether I would be able to cope up with it. And also, I felt like it would require some really, really horrifying physics knowledge, but, but actually turned out good in the end. I mean, I was supported, and I actually enjoyed it a lot, and it really gave me, it had a tremendous impact on my future plans of research, because I never knew that physics and coding would be so interconnected. So after this project, actually kind of really narrowed down what I want to do in the future. So I felt like I want to do a PhD in quantum information theory and research on quantum many body problems, because those involve a lot of interactions, and hence they require computational techniques, very heavy ones.
Wow. Well, it sounds like this is the absolute perfect sort of stepping stone to get you to where you want to be. That's fantastic. I admire how driven you are and how, certain you are as to where you want to go at such a young age. That's really inspiring. And so you enjoyed your time with CCIR. That's always great to hear. I wonder if you could give us just to wrap up, top tips for anybody considering applying to CCIR, how you would go about the application, and any words of advice.
Yes, so I mean, I would really recommend, it's a really cool experience working with CCIR, and it would be really useful for a high school student who wants to have some in-depth knowledge in their field of interest. At CCR, I could actually get some knowledge about how the field of physics actually works, what kind of techniques are used, and it really helps to get some guidance from a really knowledgeable person in that field about different courses and what kind of techniques they use. And it's also a great way to improve logical and research skills. So I would highly recommend it to a high school student.
That's amazing. Thank you so much. It's been a pleasure to talk to you, Sricheta. Sounds like you absolutely got your future lined up, and it's going to be fantastic. So it was so interesting listening to you talk. As always, I'm completely blown away listening to you guys, young people who are so inspiring and so switched on. It's fantastic. I wish you all the luck with everything. Thank you for coming on the podcast today.
Thank you very much for the opportunity.